Okay, we're going to finish off notes for today. So I'm going to start with finishing off these last two examples that we didn't get to on our notes the other day. And if you remember, we were talking about what has to happen in order to prove or show that lines are parallel. So on number 5 here, we're going to start with, we've got looking at lines L and M, and we want to show like what would B have to equal in order to make those lines parallel. So if I'm looking at those two with our two green parallel lines, that means that this line here would be our transversal. And at 3b minus 15 and b minus 5 right now, that's not one of our special relationships. They're not alternate interior, corresponding, etc. However, what I can do is I do have some vertical angles here. So if, just kidding, let's try that again. So if b minus 5 is over here, I can look at the vertical angle and know that this is also b minus 5. And if our 3b minus 15 up on top there, I can do my vertical angle and also know that this is 3b minus 15, right? So now that I know those two angles, I can look at these two. And if I'm trying to show my green lines are parallel, those would be same side interior, and I need them to be supplementary to say that those two lines are parallel. So I'm going to set up my equation where 3b minus 15 plus b minus 5 would have to add up to 180. And then we can solve. So our 4b would equal 200, which means b is going to equal 50, right? So that means in order for our two green lines to be parallel, b has to equal 50 to make all of those angle relationships true. Okay, so it's very similar to what we were doing before. It's just showing that the lines are parallel rather than knowing they're parallel at first. Okay, same thing kind of here on number 6, except now we're looking at two different pairs of lines to see if they're parallel. So I noticed right away that these two both have x's, and this one over here has a y. So I probably want to look at my x's first to solve for that, so that then I'll be able to use something else to solve for y, right? So if that's the case, if I look at those two angles, notice that they are both on this pink line here as their transversal. They both use that pink line to make their angle. So then that means I'm going to look at these two lines as my potential parallels, right? So looking at those two angles, the 3x plus 20 and x plus 50, those are alternate interior angles. So if I want my green lines to be parallel, those angles have to be congruent. So I'm going to say that x plus 50 needs to equal 3x plus 20. And then if we solve here, we get a 2x over there and a 30 here. So our x is going to equal 15. And that would make that green set of lines parallel, right? Now, if I go over here to my 2y minus 5, that's on my green line, but that's going to use the green line as a transversal, and it's also on there with the x plus 50, right? Now we can take the 15 here and plug it in for x. So if I substitute in my 15, then 15 plus 50 means this is a 65-degree angle. So now, if I think about the pink lines here and deciding if they are parallel, I can use my green line there as my transversal. So then that means that the 2y minus 5 and the 65, those are same side interior angles, and I need those to be supplementary. So I'm going to set up an equation to say my 2y minus 5 plus, and I'm going to use my 65 because I plugged in the 15, should add up to 180. And then we can simplify. We get our 2y should equal 120. So y should equal 60 or 60. Okay. Very similar to the problems we did before. Like I said, just kind of thinking about them a little bit backwards. Why my OneNote keeps doing that, but there they are. Okay. All right. So now moving on to proofs. So we're going to do several here where we're trying to show that a set of lines is parallel. This kind of box here shows you all of the different theorems or ways that you can show that two lines are parallel. And these 6 things here are those same theorems that we did back at the beginning of the notes up here, right? So all of these theorems are ones that we can use to show that lines are parallel. Okay, and I'll kind of show you how to abbreviate them when we use them in the proof. Okay, so our first one, we start with our given information, right? And in this one, we're given that ray BE bisects angle DBA. So I'm going to start with just marking up my picture. So here is ray BE, right? And it bisects angle DBA. So that would be this angle here, right? So if that's the case, remember that means it's cutting that whole angle in half. So that means that our angle 2 and our angle 3 are going to have to be congruent, right? So I can mark those on my picture. Do a little better job here. There we go. Okay, so we've got that marked. And then we also know that angle 3 is congruent to angle 1. Well, since 3 already has a mark on it, I'm going to put the same mark on angle 1, right? And notice now that also means that angle 1 is going to have to be congruent to angle 2. They all have that same marking. Now, that's not necessarily told to us in this given information, but just by marking up the picture, we already see something that we can probably keep writing down in our proof, right? And then what we're trying to prove is CD is parallel to BE. So on these, I like to kind of highlight those lines so I remember which ones I'm thinking about. So I'm going to look at CD as one of them and BE, right? Those are the lines we're trying to show are parallel. So now notice the way we can prove them parallel. Remember all these 6 things, looking at those different types of angles. And I see right now angle 1 and angle 2, if I look at DB here as a transversal, those are alternate interior angles. And we've already got a marked congruent. So if I know those alternate interior angles are congruent, that shows that my 2 pink lines are parallel. So just by kind of walking through that proof and marking up the picture, we've got our proof. Now we just have to write everything down, right? And if you have to kind of make notes over to yourself, like before you write down, that's totally fine. But basically what we just talked through in the picture is what we're going to write down for our proof. Okay. Okay. So we start with our little chart here, our statements and our reasons. We're going to start with our givens always, right? So our first part is that BE bisects angle DBA. And we also know that angle 3 is congruent to angle 1. And those are our givens. Okay. Okay. So then remember, the next thing we did was we looked at that BE bisects angle DBA. That's an angle bisector, right? And we said, well, if it bisects that angle, then that means that it cuts that angle in half, and angle 2 and angle 3 are the same. So let's write that down next. So I'm going to say angle 2 is congruent to angle 3. And the reason we know that was because of that angle bisector, right? That's the definition of angle bisector. That's where that information came from, right? Because I knew I had that angle bisector. Okay, so then we noticed, right, once we marked these congruent, we noticed, well, we're also told that 3 is congruent to 1, right? And that's a given information, so I don't have to write it down again. But we noticed that then when we made those marks, that also means that 2 and 1 are congruent because they have the same marks, right? So now I can also write that angle 2 is congruent to angle 1. We just have to think about, well, where does that come from? Well, we had this information and we had this information that's given, right? So if 3 is congruent to 1 and 3 is also congruent to 2, then that means 2 is congruent to 1. And this is one of those where you can use either answer here, but technically it would be at the transitive property. But I'm okay with substitution here as well. Okay, so either of those are okay. Okay, then as we were marking up our picture, we said, well, those angles are alternate interior, and now we know they're congruent. So if they are, that means our lines have to be parallel because we've got alternate interior angles congruent, right? So now we're ready to say that line CD is parallel to line BE, and we're going to use one of our theorems from the beginning. So we're going to say that because I know, right, if, we put the if part first, alternate interior angles are congruent, then that means my lines are parallel. Okay, and you do have to write both of those parts, and they need to be in that order. Because I know that my alternate interior angles are congruent, that means that my lines are parallel, right? This is what we had to know, and this is what we had to prove. Okay, ta-da, there's our first one. Okay, hopefully you followed along okay there. If you've got questions, let me know. All right, let's try another one. Same idea, we're thinking through all those things, right? So again, I'm going to start with, what can I mark up in my picture? Well, we've got two things here telling us things are perpendicular, right? So BE is perpendicular to DA. That would be this line and this line, right? When we have perpendicular lines, those make right angles. So I'm going to make myself a right angle there. And you can put it on both sides. I'm going to put it on one. That way I know the other one is. And then we also know that CD is perpendicular to DA. Right? So then this one's also a right angle. Okay? And then we're going to try to prove that angle 1 is congruent to angle 2. Well, here's our angle 1 and here's our angle 2. And again, I notice that 1 and 2, if I think about those two angles, right? If I look at this as a transversal, and then I think about these lines here as being my parallel lines, those are alternate interior angles again, right? It's pretty similar to this picture. It's actually the same exact picture, just some different given information, right? So again, if I can show that those lines are, or if those angles are, or I'm sorry, if I can show that those lines are parallel, then I'll be able to say that those angles are congruent. We're kind of doing it a little bit backwards this time, right? Before, in this one, we found out those angles were congruent, which meant those lines were parallel. Now we have to find a different way to show that these lines are parallel, so then we can say those angles are congruent. Okay, so let's see what we can do. And I'm betting it's probably going to have something to do with those right angles, right? Since they gave us that information. Okay, so let's set up our proof here. We start with our givens. So BE is perpendicular to DA, and also CD is perpendicular to DA. And by the way, if you think you know where to go from here, pause the video for a second, try the proof, and then come back and watch. I cannot tell you how valuable it is to try it all on your own, make a mistake, and then see the right answer, and then you'll make those corrections in your head. It's really, really valuable to do that. And don't feel bad if you get it bad, or if you get it wrong. I probably bet a lot of people will. But I promise it will help you more if you try these on your own and then look at the correct answer. So if you want to do that, pause it. Okay. So then our first reason is given. Okay, then from here, we've got our perpendicular lines, right? Now, a lot of times when we've got perpendicular lines, we go to say that things are right angles. But if I go back to my reasons up here, we've got the one here that talked about show both lines are perpendicular to a third line. Well, that's kind of what we have, right? If we look at my two pink lines here, they are both perpendicular to DA, right? So that would show that our lines are parallel. So we can go straight to that. So I'm going to say that CD is parallel, oops, put my line here, to BE. And the reason I'm allowed to say that, just go straight to it, is because both of my lines there are perpendicular to the same line. So we can say our two lines that are perpendicular to the same line are parallel. Right? Two lines perpendicular to the same line are parallel. Ta-da! So now we've got our parallel lines, and then once we know we have parallel lines, all of those angle relationships come back. So now if we look at that angle 1 and angle 2, those are alternate interior angles, right? So now we can say that angle 1 is congruent to angle 2. And now the reason we know that, this time it's going to be backwards, right? This time we knew the lines were parallel first, and then that means that our alternate interior angles are congruent. So if I know my lines are parallel, I'm going to say parallel lines implies or means that alternate interior angles are congruent. Okay, and see how we did that one in the different direction from this one up here, right? This one we had to show the angles were congruent to get parallel lines. Down here we got our parallel lines first, and then we showed the angles were congruent. Okay, and you'll use those both directions. Okay, one more proof. And again, pause the video, try a couple things, see if you can get anything out of it, and then if you get stuck, come back and watch. Okay, it'll be helpful to do that. Try to mark up the picture at least on your own if you can. Okay, so in this one, we've got angle C is congruent to angle 3. Notice there's only one angle at angle C, so I can name it with one letter. So here's my angle C and my angle 3. I know those are congruent. And then we also know that BE is perpendicular to DA. So again, like last time, that's this line and this line, right? So that would mean that we've got two right angles there. And then we're trying to show that CD is also perpendicular to DA, right? So that would be this and this one. So we're trying to show that's a right angle is where we're headed, right? Now again, I notice that we've got this set of like lines here, right? Kind of like we did before. So again, if I can show that those lines are parallel, we had a theorem last time we talked about our theorems that said if lines are parallel, then they would both be perpendicular to the same line, right? So if I know this one's already perpendicular, that means that one would be too. Okay, oops, I lost my pink there. Okay, so let's work on trying to show those are parallel. Well, I've got this angle and this angle, right? And if I think of this line up here as my transversal, then that means that angle C and angle 3 are corresponding. So if I can show those two angles are congruent, that means my lines are parallel. Well, we're already given that they're congruent, aren't we? So that's where our proof is going to go. Okay, so let's start writing some stuff down here. But you can see how I kind of think through what I'm going to do before I start writing anything down. Don't just make a chart and then say, like, I can't write anything down. You've got to start thinking through things. Make little notes to yourself off to the side and see if that gets you there, right? Okay, so my first part is my given. Angle C is congruent to angle 3. Oh, and we also have BE is perpendicular to DA. And those are our givens. Okay. Okay, the next thing we wanted to show, we said, well, if we can show those lines are parallel, we're going to know that they're perpendicular to the same line. And we said, well, angle C and angle 3 are corresponding and they're congruent, so that means that they're parallel. So I can go straight to line CD is parallel to line BE. And the reason we can say that is that if my corresponding angles are congruent, then that means that my lines are parallel. Okay, oops, I put the R in there. Lines are parallel. That makes more sense. Okay, and then once I know that those lines are parallel, well, if they're parallel, then they would both be perpendicular to a certain transversal. So now if I think of this as my transversal, then that means I can say CD is perpendicular to DA. And here our reason would be that if we've got a transversal that is perpendicular to one parallel line, then it's perpendicular to the other. Okay, and a lot of these theorems, as long as you write it in a way that makes sense, if you don't remember the exact words that I write down, that's totally fine. Okay, so there's some examples of a couple of proofs. They're not long proofs. You just have to be able to think through the reasoning and how it works. Okay, so on your homework 4, the second half of it is several different proofs to try. Again, try them. You're going to get them wrong several times, and that's totally fine. And then once you try them and get them wrong, look at the answers, see if you can figure out why it is what it is and why it shouldn't be what you wrote down. Okay. The answers for homework 4 are kind of written in paragraph proof form, so that it's not exactly the answers, but your answers, you can still write them like this in the T-chart, or the 2-column proof, but that paragraph is meant to help you kind of think through what the answer should look like. Okay, we will do some questions next class, and then after we do questions, look at things, we'll again try our second quiz, where there will be one full proof on it for you to try. I want to see where everybody is. Okay, I don't expect perfection at this point. I just need you guys to try them and see how we're doing. All right, I will see you guys on Thursday or Friday.